Welcome to this channel again. Today we shall be handling subnetting of class A in class B networks. In a previous video we had a look at class C subnetting, so stay tuned as we begin. Just to remind ourselves, subnetting is a process of dividing a large network into multiple smaller networks. As a network administrator, you can be given an IP like this, but by just looking at this can be able to create other smaller networks within it. So the process of dividing that is what we're calling subnetting. Something to take note also is we have what we call the CIDR value, which is the classless interdomain routing. This is basically the total number of bits in a given subnet. For example, if you have /8, it means you have 8 network bits in that given network. If you have /16, you have 16 network bits in that given network, which means the /16 means you have 16 bits turned on or having ones in that given network. So we're going to proceed with our process of subnetting in this short video. Here are examples we're going to look at, and I believe at the end of going through this, you should be able to handle this at your own, with your own efforts anytime you're given it. Let's get started. Okay, so we have our first network, which is 109.8.50.110/15. First of all, /15 is the thing we shall first handle first. What does this mean? This means we have 15 network bits in our given network. That means we have 1, 2, 3, 4, 5, 6, 7, 8 in the first octet. 1, 2, 3, 4, 5, 6, 7, which is 14, which is 15, and then 16 is the 0. That's the second octet. Then the rest will be zeros. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So by looking at this, we have all these are full. These others are all zeros and they are full, but only this has some values 1 and others 0. So which means our target in our network will basically be this given octet here. So what do we know? So far we know that in our network we're going to have 109, that's the only value so far we know, and then the rest we first have to leave it blank. Okay, now since this second octet is our target, it means we can now go ahead and find out how we are going to have these boxes here filled up. Okay, now we have already converted this into binary, and this is what it can give us. Now the next thing that we shall need to do is also to convert this 8 into binary. So that 8 simply means we have 8 to binary. This would give us 4 for 8, remainder 0. Here you have 2 again. You have 2, remainder 0. You divide again by 2. You have 1. You have 1, remainder 0. So which means converting 8 into binary will give us such a value here that we're seeing here, which means we shall have 1, 0, 0, 0. However, in our octet we always have 8 bits, so which means other zeros will appear behind here to make the 8 bits. Now, to find the value for our network that is going to be here, for our network ID, it means we shall have to map the value for /15, which is this particular octet here, and this value here. So what I mean by that is we're going to copy this /15, which is this, its value is here, and then our 8 is here. So mapping it simply, we're going to do some bit of truth tables, or basically some bit of multiplication. 1 by 0 should give us 0. 1 by 0 should give us 0. 1 by 0 should give us 0, 0. This other one is 1, 0, 0, 0. So now, the value that we have here, which is 0, 0, 0, 0, 1, 0, 0, the only one here that we have is the representation for the network that we're going to have. So this one here on our table is in position 4 from the left, which means 1, 2, 3, 4. It is on position 8, which means our first value, our network ID, is basically going to have 8 here. So if it's going to have 8 here, then it means having found this value, then the rest are going to be zeros and zeros. So that becomes our network ID. Now, how do we find the broadcast ID? Maybe also to explain how I found these zeros. Having gotten 8 here, you'll also say if all these are turned off, you have 0, and also if all these are turned off, you have 0. Now we shall go to our broadcast ID. Now, to determine the broadcast ID for this network, having found the network ID, we shall need to find what we call the magic number. And the magic number is often the last bit that is turned on in our /15 network bits. The last one that is turned on. So the last one that is turned on in our table here is in position 2. So it means our magic number is basically going to be 2 because it's the last one that is turned on right here. So it's position 2. So this simply means our network is going to increase by 2. And so that simply means that if we add 2 to this network here, it will give us the next network ID of that network altogether. So it means adding 2 would mean we have 10. Okay, but then this 10 here is basically the value for the next network ID. So to get the broadcast ID, it will mean we're going to subtract that -1, because the broadcast ID is always less of the next network ID. So which means instead of having 10 here, we're going to have 9 here. So then, if all these bits are turned on, we're going to have 255. And if all these bits are also turned on, we're going to have 255. So it means what we have here now is our network ID and also our broadcast ID. I hope so far we are together. Now then, how do we find the first usable IP and the last usable IP? We're simply just going to say the first IP will be between 109.8.0.0 and 109.255 and 255. Maybe this is confusing when I use these tables, but it's okay. Let me now let me merge these tables and also merge these so that I can just write it down so that it doesn't confuse you. Okay, so now it means our first usable IP address will be 109.8.0.1. That will be our first usable IP address. And then our last usable IP address will basically be 109.9, because that's the value we got, .255.254. So this is remember, this is the broadcast IP, and so our last usable IP must be one IP address less of the broadcast IP, which means this is our answer in that kind of case. So I hope something has gotten into your heads. Let's try the second example. We have this other IP address here which has a /22. Let's copy this and paste it here. So what does /22 mean? /22 simply means we have 22 network bits. In the previous example, we had 15 network bits. Now here we have 22 network bits. And so by listing them, we have, let me do this. we have 1, 2, 3, 4, 5, 6, 7, 8 in the first octet, 9, 10, 11, 12, 13, 14, 15, 16 in the second octet. Remember, each has 8 bits. 16 is where we've stopped. 17, 18, 19, 20, 21, 22, 23, 24. So it means this time around, all these bits are complete. Even this bit is complete. It's only this third octet which has some bits having ones and other bits having zero, which means our target on this IP address will basically be the third octet. Okay, now if the third octet is what we're going to find out, it means what do we know? What do we know about our IP address? Which means for now we know that our network is going to have 172 and 16, and also it will have 172 for the next network for the broadcast IP and 16. What we don't know is this part here, but also this last one now here, what we shall only say is if the last one is turned all off, we shall have 0, and also if this one is turned on, we shall have 255. Therefore, what we're looking for is the value which is going to be here for the network ID and also which is going to be here for the broadcast ID. Let me also remove this from here. Okay, now how do we find these values for this part? To find the value for this part, we shall have to first of all convert this value, which is the third octet, into binary. So here we're having 85 is what we're converting into binary. So this is 85, and so let me remove all this. Remove all this. Okay, 85 by 2. What do we get? We get 42, because 42 by 2 will give us 84. So it means we shall have a remainder of 1. 42 by 2 will give us 21. Remainder 0. Okay. 21 by 2 will give us 10. That is for 20. Remainder 1. 10 by 2 will give us 5. For 10. Remainder 0. 5 by 2 will give us 2. For 4. Remainder 1. Then finally, 2 by 2 will give us 1. Remainder 0. So now our result after converting that into binary would be the value we'll write from down going upwards, which is 1 0 1 0 1 0. Okay, what have I written? 1 0. Okay, 1 0. Okay, 1 0. Okay, then 1. 1 0 1 2 3 4 5 6 7. Okay, 1 0 1 0 1 0 1 1 2 3 4 5 6 7. Then it means the other, to make it 8, there will be another 0 right behind there. Okay, so now this is after converting this into binary. Now the value we have gotten here, we shall have to map it. We shall have to map our /22 onto this value here. So that means the value for /22 in this octet here, we shall pick this value because that's our major octet we're working with. We transfer it down here. This is /22. Okay, we're mapping it to 85, and 85 has given us this value here. Okay, we paste it here. I don't know why it is okay, we paste it here. Good. And then we now get our result down here. By mapping these two, we have 0 1 0 1 0 1 0 0. So now, having mapped this, it means these values turned on will give us the value for our network ID right here. So this 0 is turned on. We have this one here, this second one here is in this position, which is 64, and then that is 64 plus okay, 64, and then this other one here is in the 4th position after 64, this one here, which is 16, and then the last one, which is this one here, is in the 3rd last position, which is this one here, which is 4. So we write here 4. So by adding these 64 plus 16 plus 4, this should give us 84. So 84 will be the network ID for this network that we have here. Now, having found that, how shall we find the value for the broadcast ID right here? Now, the value for the broadcast ID, we shall need to find the magic number. And the magic number, I said, we find it from our /22 in this case, so which means we shall have to find it from here. And the magic number will basically be the last bit turned on. And this last bit turned on is in the position of 4 right here, because this is 1, 2, 3, 1, 2, 3. So this is in this position, which is 4. And this simply means if our magic number is 4, then it means in our network basically increases by 4. So now that means that if we add 84 plus 4 and get 88, that 88 is the network ID for the next network. However, to get the broadcast ID, we shall have to say 88 minus 1. We have to subtract the network ID, the next network ID, by 1. So instead of having 88 here, we're going to have 87. Therefore, having found this, the rest now become obvious. The first usable IP address will be 172.16.84.1. That's the first IP we give to our client. And then the last IP would be 172.16.87.254. That's the last IP you can give to our clients. So this is basically how we handle Class A and Class B subnetting. Let's look at the final example, which is this one here. Okay. This one here has a /29. So /29, what does that mean? /29 simply means we have 29 network bits. Okay, so we'll first remove all these so that we can do it very well. We have here already 8 here, 8 here, those are 16. We'll continue 17, 18, 19, 20, 21, 22, 23, 24. That's also full. 25, 26, 27, 28, 29, 30, 31, 32. So now, by looking at this, all these are turned on, and only this one has a mixture of 1s and 0s. So this will be our target, which means our last octet here is going to be our target in this number. So it means, what do we know? All the first 3 octets are going to be constant. They will be repeated here. So we shall have 172, and we shall have 10, and also have 50. And then the same applies to this table also here, like that. Now what we don't know is the value that's going to be here and what's going to be here. Then how do we find the value that's going to be here? That's going to be here. It means we shall get this 16 here and convert it into binary. So we have all this removed from here so that we can have a clean one. So we're converting 16 right here. 16 into binary by 2, you have 8. Remainder 0. By 2, you have 4. Remainder 0. by 2, you have 2, remainder 0. Then by 2, finally, you have 1, remainder 0. So what is our result? After doing that, we're going to have 1, 0, 0, 0, 0. So these are 5 bits. So we can add other 3 right behind, which will still be the same as 16. So now, having gotten this value, having converted this into binary, then we shall go ahead and map this value and map /29 onto this 16. So what do we do? Our 16 is the representation of this. We'll copy this. Okay, we'll bring it down here. This is that's /29. Sorry, we're mapping /29. Sorry, we're mapping 29 onto 16. So 29 is represented by that value there, and then our 16 is represented by this value right here. Okay, so we also put it here. Good. So now, what values are we going to get? When we map these two, it means we are going to have 0, 0, 0, 1, 0, 0, 0, 0. So it means our result tells us that the only one turned on is in the position 4 from your left. 1, 2, 3, 4, which is 16. So it means this is 16. So the value I've gotten here immediately becomes the network ID for our network. Then, after finding network ID for our network, we shall need to find the broadcast ID for this network. How do we find the broadcast ID? We shall have to find the magic number. And the magic number is found by looking at the last bit of our /29 in this case. So our /29 in this case is in position 5 from your left. So it means you come here 1, 2, 3, 4, 5. It means our magic number is basically 8. So that means our network increases by a value of 8. So now, having gotten this magic number, how do you find the broadcast number? By adding the network ID of the network that we have currently, which is 16, to the magic number. That will give us 24. But that 24 is the value for the next network ID. So therefore, to get the value for our broadcast, it means we shall subtract the next network ID, which is 24, minus 1, which will eventually give us 23. So when we get 23, we already now have our network ID and also have our broadcast ID. So what would be the first usable IP addresses that we give to our clients? The first one will be 172.10.50.17, because right from this one here, the immediate next IP address is the one we give to our client, and then the last one will be 172.10.50.22, because remember, our last IP address does not exceed the broadcast IP address, which means this is how we solve these numbers. So I believe this should be able to suffice as far as IP addressing and subnetting in class A and class B is concerned. Thanks for watching. Subscribe so that you can be updated about any new videos that we shall make. Thank you for watching.